Hi, I'm Johannes. I'm in my 4th year PhD student here in Erlangen. As you may see from the background of my slides, oh no, it's again this. I'm also like Tamas working on KM3net. So I'm not mainly in my analysis working with Julia, but so parallel to my work, I try to contribute to the Julia Hep environment, and also, for example, with this package, Corpuscles. So mainly, how did the program or the idea come up? So if you sit at your desk and you have your both screens of your computer open, so in the one thing you have Julia open, on the other side you need the information from the PDG. Then basically, before Corpuscles, or at the time we put that project up, you had the chance to look up the values and just hard code to your project, or use the existing Python project. I think the Python project has nothing fancy binding, so I think you could just also use that library in Julia. But both of those options are a little bit, so I was sitting like this there, so it's not really it's not really that's what you want to do. And so yeah, we came up with the write a native Julia package for this. So that is where Corpuscles came into play. So as I said, it's a native Julia package, and just as we basically do the same thing like the particle package in Python, we took the CSV table from there, which is mostly like the official CSV, but just some errors are corrected, so for the parsing. So it's mainly focused on the information encoded with the Monte Carlo ID, or this PDG ID. So for the talk right after me from Mikhail, so I think the PDG DB can provide a lot more. So I hopefully we can merge this a little bit, so that we have the Corpuscles front end with all the information the database in the background can provide. But for now, let's stick what we have with what we have. So and a special thing I was looking at is that all the values are given with unitful, that you are sure that this is the correct value, because from depending on with whom you work with, and then you say there's a fixed definition. For example, I give my mass in GeV, but there's always one who says for me it's standard that it's MEV, and then this confusion comes up. So just to make sure it's given in unitful, so no confusion about this. So if you this is where you mainly could start with. So you take the corpuscles, and then you can just create a particle by its ID, for example. So it's an electron neutrino here. Then you can print the basic properties, and I want to highlight a little bit how it's stored. So it's a little bit difficult for me to keep up with for example, with Jerry and Tamas with the fancy things they did. So it's not on that level, but here what is done here is we have a struct for the measured value, and here I did not go for the measurements.jl, because I think for some fields you have different values for the upper and lower limits of your uncertainties. And as I said, it's all given with unitful, and so you have here the quantity with its dimension and the unitful unit, and so you can really be sure about what you get there. That's the first thing. And the other thing, when we come to a little bit of benchmarking later, that's also important to know what's happening there, because I think the Monte Carlo ID, it's basically an integer, and when you then look inside the code, then you see this. And maybe at some point, if someone is not too familiar with the PDG ID, maybe you will then have this look. So what the hell is going on there? Why you are doing that stuff to the integer, which should just be for the lookup in the dictionary. But for all the helper functions we implemented, we also go by for the information, not just by a lookup, so also by the definition of the PDG ID. So in theory, you could also put in a PDG ID and check for properties, even if it's not contained in the CSV table, because it could be that for the digits in the number, this information is contained. So, okay. Yeah, as I said here, that's because of then we have some additional information in the PDG ID. Here is a list of the helpers. So as this is a short talk, I was not sure if it's I can do a real hands-on if that would fit in. But here as a short overview, so we not only have the PDG ID, we also have a mapping for Python ID and GL3 IDs. And here, these are mainly the helpers we implemented. So which, yeah, are the main ones to be useful. You want to check of the particle, what are the properties? And yeah, with that, here is yeah, a little benchmark I did. So what did I do? I just collected the IDs which are in the database and sampled some of the PIDs and checked, okay, what is the time I need to really get into this? As I said, there is everything is given as a unit full value to, yeah, okay, then you, for example, want to have the mass, then the value of the mass, and then the actual value without the units. And then this is what you get out. So yeah, on the nanosecond scale. But if you compare it just to a dictionary, you see, yeah, okay, we maybe for factor 10 off. Yeah. And this is why I explained how we parse the PDG ID, because this also takes a lot of this time to actually parse it every time and then do the lookup. Yeah, so that's main thing you need to know about this. But yeah, in the end, it's a big lookup table in Naive Julia. And if you want to play around a little bit with this, I put into the Indico, I put a Pluto notebook and some CSV with some dummy particles. So this was from one of my main work, is working with neutrino generators. And this is from one of the generators, a Gibu output, just as a CSV, and then put, as we learned yesterday, with data frames, put into a data frame and then play a little bit around with it. So if you're interested with it, you can just have a look and can, yeah, check what it can do and what it cannot. So as I said, yeah, so this is, leads me to the summary. So this is, yeah, could also be the title, not too fancy, but very helpful. And the planned improvements is, as I said, some cooperation to the PDG DB.jl, which would give you then even more helpers. Also, the idea was to expand it to whole nuclei, but there I think we should then also provide some of a transition to the interface of periodic table.jl. And what is still for a long time to do, I think also for the docs, a JOS paper would be also still nice, but yeah, that's at some point it will come. Yeah, thank you.